Hi everyone, hope you're all doing well. What we're going to do today is we're going to take a look at sections 5.1 and 5.2 that talk a little bit about normal distribution. All right, so that is going to be our focus of this video. The information from your textbook, section 5.1, begins on page 160. Okay. And one of the things you are going to need to be able to access through your textbook is what is referred to as Z-score tables. You can find them there in the appendix section of your book, and it's on page 370 and 371. Now, if you have access to printing those tables out, it would be probably a good idea. I will post these tables. I will print them, scan them, and post them for you up on Canvas, so that it's easy access, but to actually have them in your hand usually makes the work that much easier, so you're not changing from screen to screen or flipping from one page in the book to the next. So just a recommendation, because we will be using these during this chapter 5. Okay, so I'm going to need to erase this. I have a relatively small board that I'm going to be working off of. And so I can only put on a little bit at a time. I will make sure that I am always available with Zoom. I am going to be sending you a link to that. So hopefully by the time you look at this video, you've already read my email and we already have the Zoom link up. All right. So let me clear this off, and we're going to get started talking about normal distribution, and I apologize for any blocking of the board that I do here. I will try to get out of the way as soon as possible. All right, so what's a normal distribution? So what is a normal distribution? So a normal distribution is when data is graphed, all right, and we're going to have this smooth curve. So I'm going to have this, basically this x-axis right here. Now we all know my inability to draw, but we're going to have a curve, all right, that's this nice smooth curve, kind of looks like a hill or a mountain. And what happens with a normal distribution is the high point, the max point on the curve, this right here, is going to be a combination of your mean, your median, and your mode. So when we looked at data that was graphed and we had skewed to the right, skewed to the left, or symmetric. So we're looking at that symmetric graph. Now, when we use a normal distribution graph, right here on the graph, right here, we're going to be looking at the mean. Okay? Now, if you recall, when we were finding the mean of the data, just mean, median, mode. Right here's a little aside over here. The symbol that we used for mean was that X with the bar over the top. For a normal distribution graph, we are going to be using the Greek letter mu. That's mu. All right. So you should be used. You're going to see that. Excuse me. When you are working through my stat lab and looking at some problems in your book. Okay? So mu. Now, this curve with the mean in the middle, we are then going to use our standard deviation. Okay? So we'll use our standard deviation for this curve. Now, this is what happens. So let's just say that you calculated a standard deviation. And the symbol for standard deviation, by the way, is going to be sigma. It looks like a cursive O. So let's just say that the standard deviation is equal to 10. So what happens along this x-axis of our normal distribution is we are going to move away from the mean in chunks of 10 units. All right, so it's sort of like a sequence. So what happens is in the middle here, this is where our mean is. This is where the standard deviation is equal to 0. Okay, so we say that the standard deviation is equal to 0. Now, what happens is we're going to go 3 units to the right and to the left. So here we have, all right, this is the standard deviation plus 1. This is the standard deviation plus 2. And this is the standard deviation plus 3. Then when you go to the left of the mean, we have the standard deviation minus 1, the standard deviation minus 2, and the standard deviation minus 3. Right? So that's what is happening here. All right? Now, when you look at a normal distribution curve, you're not going to see these symbols in here. Okay? You're going to see values. So this is, right here, this is our first standard deviation above the mean, 2 standard deviations above the mean, 3 standard deviations above the mean. 1 standard deviation below the mean, 2 standard deviations below the mean, 3 standard deviations below the mean. So, okay, I'm going to erase this right now. So what's going to happen is, let's just say that the mean of some random data is 100. Okay? With a standard deviation of 10, this first standard deviation is going to be 110. The second standard deviation is going to be 120, and the third standard deviation would be 130. So we're adding as we move to the right. It's like a number line. When you move to the right, you're heading towards positive. To the left, you're heading towards negatives. So you're adding to the right, you're subtracting to the left. Now when we go below to the left of the standard deviation, so we're going to subtract. We have 1 standard deviation below the mean, 2 standard deviations below the mean, and 3 standard deviations below the mean. All right, so our mean is 100. The standard deviation that was calculated was 10 units, and then we add that 10, consistently to each standard deviation and to the right, and then we subtract it as we moved to the left. Okay, so that's how the standard deviations work. Now, what we're looking at when we're working with a normal distribution curve is we're looking at this area underneath the curve. That is our focus. So what happens here is, I'm going to erase our numbers a little bit. I'm going to erase these for just a moment. Okay. So what happens is this curve, if we want to try to figure out like how many of something is happening, where does the data lie? We need to be able to use the curve to answer that question. It's not quite as easy to answer as with a bar graph or a histogram or a line graph and so forth. So what we have is we have this rule that's really easy to follow. And I'm going to erase this right here just a minute. Okay? And it is called the 68, 95, 99.7 rule. And these are all percentages, okay? So what happens is, all right, if we take a look at the data, so this is one standard deviation below to one standard deviation above, this area of the graph. Okay, if I look at this right here, this area of the graph, that contains 68% of the data. All right, so let's just say that there were 100 pieces of data. 68% of 100 would be 68 pieces of data would fall between one standard deviation below and one standard deviation above. So remember that 100 that we had in here, and the 90 here, and the 110. So maybe, I don't know what this would have to do with. Maybe this has to do with some type of weight, okay? That if there were 100 weights that we were looking at, 68% of the weights would be from 90 to 110, and let's just say our unit of measurement was pounds. All right, so from 90 pounds to 110 pounds. So we could answer a question and say, oh, how many pieces of data? 68% of 100 would be 68 pieces of data. Okay? So that's the 68. Now what happens is, as you expand out, as we go to 2 standard deviations below the mean up to 2 standard deviations above the mean. So now we spread out a little bit further on this normal distribution curve. So if I look from -2 up to +2. Now what I'm going to do at this point is I'm going to erase what I have in here so it doesn't look confusing. All right. Alrighty. So there's our mean right there. And I am going to erase the 68% for right now. Okay, but if we now take a look at all of this from, okay, 2 standard deviations below the mean to 2 standard deviations above the mean, this here would represent 95% of the data. Okay, so again, we've got that 100 pounds with a standard deviation of 10. So now we're at 80 pounds and 120 pounds. Okay, so we had 80, 90, 100, 110, 120. So what we're saying here is 95% of the data will fall between 2 standard deviations below the mean to 2 standard deviations above the mean. So again, going back to saying maybe we have 100 pieces of data, 95% of 100 is 95. So 95 pieces of data are going to fall within this part of the normal distribution curve. All right, it's right in here. That's how many pieces. All right, last part is 99.7. So let me get my eraser again. Let me erase what I have on here. All right. So as you may have guessed, we'll go out to 3 standard deviations above and below the mean. So I'm 3 below the mean over here on the left, so I'm at that 70, because I subtracted another 10, since that's what the standard deviation is, and I'm going to go 3 above, and that's going to take me to 130, because now on the right I added 10, all right, since the standard deviation is 10. So now my data is extending, all right, from 3 standard deviations below the mean to 3 standard deviations above the mean. So almost to the tail ends. And that leaves you, that is 99.7% of the data. It's almost everybody. Okay? So again, if you had 100 pieces of data, 99.7 of them would fall into this part of the graph. So then what happens is we have these extremes left over here. All right, so they're those rare cases, alrighty? So maybe if we were talking about IQ, or you're talking about certain scores of certain games, all right? The extremely high, the extremely low. Those outliers that we spoke about when we were talking about means before, they're going to be on this end. Now notice, we only have 0.3 left. If it's 99.7 to here, to get to 100, we only have 0.3% left. So that's a total on both sides. So this is going to be, these little guys over here are 0.15 and 0.15% of the data. So very, very little. Right? So that's how we are going to be taking a look at this. Now, I'm going to erase this and divide the graph up again, because a lot of our questions about the normal distribution curve come from, all right, let me get this out of the way. A lot of our questions deal with not just between from -1 to +1 standard deviations of the mean. Often, we're looking at different kinds of chunks. Okay, so here's my mean, all right here. And I've got my -1, -2, and -3 right here. 1, 2, and 3 right here. All right, so what we had just said was that from 1 standard deviation below the mean to 1 standard deviation above the mean, that represented 68% of the data. But we can divide that in half right at the mean. All right, and this is going to be 34% and 34% of the data. All right. So then, all right, if we go out to that 95%, okay, so I'm going to erase this again. So when we go from 2 standard deviations below the mean to 2 standard deviations above the mean, all right, we can then say, if we divide that in half, so 95 divided by 2 is 47.5, I believe. So that would be 47.5% of the data straight down the middle. All right? Okay, and then when we move out to that 99 and 0.7%, all right, so this is all 99.7%. So I think we have what? 49 point, I don't know. Is it 49 is 98? Right. I think it's about 49.75, 49 point something %. Okay. for half of that. So just making sure that when you take a look, that we are good with making sure that we understand that. So half of our data will be to the right of the mean, half of our data will be to the left of the mean. Okay? So let's do this. Let's just take a quick scenario and let's say the following. All right? Let's say that we've got 500 students. Okay. Let's just say they took a stat exam. All right, and the mean of the stat exam was 85, and that the standard deviation for the stat exam was 15. All right, so this is information that normally will be given to you. All right, so I'm going to take that information and I'm going to put it on a normal distribution curve, okay? All right, so if this is my mean right here, I'm going to put my 85 here. And you know what, let's change that 15. Let's just say it's a standard deviation of 5. That'll make a little bit more sense. All right, so when I add and subtract my 5 for my standard deviation, okay, my normal distribution curve should look something like that. Excuse me, I'm going to walk in front of the camera a moment. Okay. All right, so now let's take a look at maybe some questions that could be asked about this data. All right, and we want to say maybe question number 1 is how many students earned between 80 and 90 on the exam. Okay, so you take a look at your curve. Here's our 80, here's our 90. From one standard deviation below the mean to one above, that falls into that 68% of the data. So we're going to say 68% of 500. That's how we're going to find it. All right, so we pop that into our calculator, and we find out that 340 students, okay, scored between an 80 and a 90 on this particular test. Okay, how about the second one? All right, so second question, what if we said how many students scored less than 85? Okay, so 85 is our mean. We want all the scores that are less than 85. All right, and that would be half of the students or half of the data. So we have 50% of 500. So 250 students would have scored below or above the mean. All right, let's take a look at a different kind of question. All righty, so again, I'm going to erase this here. All right, and we're going to say how many students, our third question, how many students scored 90 or above? All right. 70 or above. All right, so here we are. Let me erase that right here. All right, so we're interested in these people right there. And you know, that's not a 68, a 95, or a 99.7 at all. But here's something that we do know, all right? We do know that from 85 all the way to the right is 50% of the data. And we know something else too. We know that between 85 and 90, which is from the mean to 1 standard deviation above the mean, we know that that is half of 68. So we know that this in here is 34%. So what we can do is we can say, okay, 50% minus 34% leaves me with 16%. That 16% is this right here. So 34, we were not interested. We didn't care about the data from 85, 86, 87, 88, 89. Not interested in that. All right. What we did want was from 90 on up. So now we're going to find 16% of the 500 students. So we pop that into our calculator. All right, and we find out that there were 80 students or 80 pieces of data, all right, that fell from 91 up. All right, let's take a look at another one of these, okay? So let's say how about if we said between, our fourth question, between how about a 75 and a 90? How many students fell into that category? All right, so I'm going to clear off my normal distribution curve here. Okay, and so let's see. I'm keeping that mean 9 in there for right now to see if maybe that'll be helpful. But I'm going to go from 75 up to 90. Okay, so let's see. What do I know? I already found out from the previous problem that this is 34%. Okay? And the second thing that I know is that from 75, which is 2 deviations below the mean, up to 95, which is 2 deviations above the mean, all right, I know that that's 95% of the data. And half of this right here is 1/2 of 95. And 1/2 of 95 is 47.5%. So what I'm looking for is this 47.5% and that 34%. So I'm just going to come over here and say 47.5 plus 34%. We'll double check any arithmetic. 47.5 plus 34 gives us 81.5% of the data. So of 500. Okay. And that should give us, all right, approximately we have 407.5 for that particular answer. So that's how we're going to use this normal distribution curve as well as this rule that we have. the 68, 95, 99.7 rule. This is a great rule. It works really well when we are working off of the numbers, off of those standard deviation numbers. But sometimes we have numbers like, what if the question was something about, what if someone scored an 82? Or what if someone scored a 99? Or someone scored a 71? You know, there's nothing on that normal distribution curve and with this rule to help us. We can get close to an answer, but we're not going to be as exact as we would like to be. So to get a little more exact from the normal distribution, this is when we use something that's referred to as a z-score. So excuse me again, I'm going to walk in front of the camera. I'm going to clear this off. Okay. And we're going to talk about a z-score for a few minutes. Now the z-score is what I was talking about with the table in the back of your book. So I just want to open up, I'm going to the back of your textbook. I'm going to lift this up. I know that all your books are online, but this is what the z-score table looks like. So this is what you'll be searching for in the back of your book on page 370. Okay? Now, so what happens, all right, with a z-score is what we do is we standardize a score. So let me put this up here, z-score. So a z-score is a standardized score. All right, so this is just a standard score. So that 85, 90, 95, 75, they were raw scores. So a raw score is going to be rewritten as a standard score. All right. Now we're going to need the same type of info that we had before. All right, we still need to know the mean. So that mean we said was 5. Okay. We still need to we said the mean was 85 and the standard deviation was 5. So we still need to know that, and then we also need to know the data. All right, so we have what's called a data value. All right, sometimes a lowercase n or an x might be used, okay? And our rule looks something like this, all right? Z is equal to, all right, our data value minus the mean over the standard deviation.